Okay, back to the book. Okay, we have finished some wrestling exercise last time. So the exercise that we have finished are these ones. All these ones until lifetime. So we haven't learned iterators, which is slightly annoying. So we can move forward. But these are all, I think, more advanced topic maybe. So we will learn those. 61.1% Grade, but we have to learn those first. So let's go back to the book. And it's an IO project, building a command line program, which is quite fun. I like hands-on exercise. I bet a lot of people like that as well. So we're gonna use all the thing we learned in chapter 7 to chapter 11, and basically, yeah, we have been recap all these things. Also, we will briefly have a sneak peek of what's go ahead as well. So what we're trying to build is to so set Rust is fast, safe, and single binary output, so we can make something like grep. Okay. Woohoo. Global research, regular expression, and print. I think lots of people already know grep. I know what is grep, but I rarely use it. Which is because I suck at it. So that's why I think I should use it more. I know it's very handy, but I am just every time when I try to do something in regex, I have to Google it and find the cheat sheet and stuff. I can't remember the syntax. Okay, so in the simplest use case, I will search a specific file for a specific string. Grep takes its argument, a file path, and a string. They read the file, find the lines that the file contains, the string argument, and prints those lines. Along the way, we'll show how to make our command line tool use the terminal feature that many other command line tools use. We will read the value of the environment variables to allow user to configure the configuration as well. The behavior of our tool. We will also print error message to the standard error console stream using standard error instead of standard output, standard out. So, for example, user can redirect successful output to a file while still seeing error message on screen. Rust community reminder. Andrew Garland has already created a fully featured, very fast version of grep called RP grep. Okay, it sounds a bit cheeky. By comparison, our version will be fairly simple, but this chapter will give you some background knowledge you need to understand real world projects such as RP grep. Of course, I bet this is a amazing tool, very sophisticated and use a lot of very fast algorithm, but we are not doing that. We just use something basic because we're learners, we're learning Rust. The main purpose is not to build a super mega amazing tool, but to learn how Rust works. So let's get started. Accepting command line arguments. So we have to start a project, of course. We'll call it mini grep, to distinguish from grep that we may already have. Let's do that. Let's go back here. We're done with wrestling for now. So let's end and go back here, and then we do cargo new mini grep. So now we have a new package. So let's go inside there, I guess. Right. First task is to make it accept is two command line arguments. So we would take two arguments, the file path and a string to search for. Then we'll be able to run a program for cargo run two hyphens to indicate the following arguments are program rather than for cargo. Yeah, because we have seen this before, right? When we run the test, I believe. Let's have a quick look. I was like, oh, why do we have to use 2-? It's because it is for the program, not for cargo. So if we look at the test, and I think it's this one, right? let's decipher something, because I had that question, and not here. Control how test to run. So yeah, you need the double dash. So cargo test dash. So cargo test dashes help display the options you can use with cargo test, and running cargo test dash help display the options you can use after the separator. Okay, so yeah, like we would actually have all these things that is for slightly interesting. So yeah, that's this like interesting syntax here, but I don't think I can't think of a very close correlation, but yeah, so we have to use dash here as well, because we are piping in our argument in our program, not cargo. Otherwise cargo will interpret it differently. So a program generated by Cargo Neo cannot process argument. We give it some existing library. On Crate, IO can help with writing a program that accepts command line arguments, but because we are learning the concept and we implement it ourselves, what a great way to learn. So enable minigrep to read the values of the command line argument. We will need to use standard environment Rx function provided in the Rust standard library. This function returns an iterator of the command line argument passed to minigrep. So iterator we'll cover later, but for now you only need to know two details about iterator. Iterator produces a series of values, and we can call the collect method to turn it into a collection, such as a vector that contains all the elements in the iterator procedure. Iterator produces. Okay, so yeah, it's like, you know, in Python, like I think a lot of people, when they start using iterator, they don't realize what an iterator actually is, because you use it in a for loop or something like that. So in Rust, I guess now we only need to use the collect to get a list back. So kind of like that. Yeah, in Python you can also like turn an iterator into a list, kind of thing. But in Rust we do use a dot collect. So with argument dot collect, then they will give us a list of arguments. So let's do that. Let's do this. So let's copy the code and put it in main. Where is our code? So minigrep. Right, so here, so we would use this. First, we'll bring the standard environment module into the scope with a use statement, so we can use its argument function. And then we it's nested in two levels of module. Yeah, it's always a good idea to have this, because then you know args is from environment. Yeah, it may be easily mistaken for a function that defines in current module. Invalid Unicode. We'll panic if argument contain invalid Unicode. If your program needs to accept argument containing invalid Unicode, use args_os instead. That function returns an iterator that produces OS string value instead of string values. We've chosen to use arg here because OS string values differ per platform, and it's tricky. But then you can have emoji if you use OS string. Yeah, kind of. So no, we make it simple. We just are going to use Unicode arguments. Well, I guess, yeah, it's fine. It's just an experimental program. It doesn't need to be super powerful. On the first line of main, we use this. Actually, we just use collect to turn it into a vector. And it's a type of to specify that we want to vector of string. So we know that it's strings here. And then collect is one of the functions you often use to annotate. Oh, I forgot to check the chat. I don't know if anybody's here. Give me 1 sec. I will quickly grab my phone. Okay, I'm back. Just in case someone want to chat, then I'm here. Okay, so yeah, we have a vector of string. So collect is one function you do often need to annotate because Rust was not able to infer the kind of collection you want. We can use the debug macro. Then with 2 arguments. So here, yeah, of course, like, cause from this code, just looking at it, even like human eyes, just looking at it, or like first, like immediately you don't know what it is, right? Like until you kind of, maybe you don't know what like arg is, and then you Google it, like, oh, you're getting something from the standard input, so maybe it's a string. But yeah, I don't think a compiler is very smart and look at the documentation and see what this is. So yeah, that's why I use .collect, because this is not obvious what it's holding, so you have to mark it. So let's run it without the argument. So here, let me clean it up first. It's a bit messy here. Oh, and it's here. So it's okay if I put it here, right? Everybody can see. I can make it bigger if people want. Oh, okay. Oops. Maybe like this. Yeah, it's fine. We're just running cargo run, so it should be fine. We have, what is it? First value in a vector is name of our library that matches the behavior of argument in list C. Doesn't say let program use name by which they were invoked. In the execution, it's often convenient to have have access to program names in case you want to print a message or change behavior of the program. But for purpose of this chapter, we ignore it and save only 2 arguments that we need. So yeah, we try to debug arg, so to see what arg is. So far we didn't put anything after cargo run, so we got only one thing, which is the name of the process. So the first thing is always be the name of the process. So if we do this, oh, what have I done? Okay, right. Then we have needle and haystack. So it's the second two. So yeah, we ignore the first one. It's just the name of the process that we're running. Notice that the first value in the vector. Yeah, so we have done that. Save the argument values in variables. So we would extract it like that. Here. So 0 we ignored it because we don't need this. We take 1 and 2 here and then put it here, and then searching for this and file this. So this is our next step. Because I'm lazy, I'll just copy and paste the whole thing. Yeah. So for example, if we do this, searching for tests in file example.txt. So we have our argument correctly. So that's the first chapter. So now we can take 2 arguments from the command line, which is great. But then how to read the file? So now we have the path, file path. We need a simple file to test it with. So let's create a text. It's poem.txt here. Where should we put it though? Maybe where root level. So that's where we run our maybe we run our code, so we'll put it here, which is like here, poem here. Okay. Then we'll add the code to read the file. So this is our print line, right? So after print line, then we will, oh my god, I have so many things, all the rustling exercises. Okay, come back here. So after this, we want to open that file. So let's content equals to read to string file path, that's from FS library. And then dot expect should have been able to read the file. So if it's not able to read the file, we just panic and say should have been able to read the file. We don't know why. But yeah, that's the error message with text, and then we have all the content in here. So let's try. So this should be poem, right? Poem.text. Let's see. Oops, we don't have the module. Did we forgot to use? We do forgot to use because it's from the standard library. So here, let's try it again. Yeah, we can read it, and we can just search for text in file with text. I'm nobody. Who are you? Blah 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 blah. So that's that. So now we can do this. Yeah, we already know what's going on, kind of. Yeah, it will return a result. That's why we have to expect here. Yeah. So run the code and we have it. So all good. Sorry, I'm kind of speed running a little bit because yeah, it's just recapping what we have learned, but this is just a FS library thing, so we have to use and then read to string. I think along the way we will learn a lot of method that we can use, and that's very important. Syntax is one thing, but learning all these built-in methods is also very important, because otherwise it will be a pain to do anything. Yeah. Okay, next. Refactoring. Oh, we are not doing a very good job of modularity and error handling, isn't it? Yeah, so it's just printing out should have been able to read the file, but what about we have like the file doesn't exist? What about other things, like for example there's index of bound error from Rust and a lot of other things. So separation, okay. Yeah, for example, if we don't have enough argument, that's also another thing we need to float in to give an error message. Yeah, so error handling code should be in one place. Yeah, in Python there's a lot of times there's an error.py that separates all the error objects from it's not necessarily error handling, it's just like a bunch of error that you can print out and stuff, and yeah, you can handle error a little bit more as well. Separation. So now we have lib.rs, and then yeah, if the logic is small, it can be main.rs. Command line parsing logic start getting complicated, then it needs to be in lib.rs, because like lib.rs we can test it, right? Main.rs we can't. Responsibility that we're calling the command line parsing logic. If the argument value set of it, any other configurations, calling run function in lib.rs, handling error if run returns an error. So yeah, I think we've talked about that before. It's good to make main remain very lean and then have most of the functionality in lib.rs, because then you can do unit testing with it. So what do we want to do? Extract the functionality of passing argument into a function. So I think first thing first, we would have to have a librs, a new file, and then so we can separate them. So we have a bunch of argument. We'll just pass it into parse config. So let's go back to main. We'll put that separately. So yeah, so after collect, we just code this instead of doing this ourselves. So here, ideally you put it in separate file, but we'll put it here for now. We'll move them later. So here we have parse config, and then we'll take in a vector of string, actually a reference of vector of strings. There's a slice basically. We return to reference, string reference, or like string slices. Then this first one, no, the second one and third one, because the first one is the name, right? Remember, return them as a tuple like that, and then we don't need this anymore. And then it will get because this will match this return pattern, and then it will just become query and file path. So this one will work. So now what do we want to do? Yeah, it seems overkill, but it's always a good idea to separate them. I think the next thing is the search functionality, or opening the file functionality. Improve path config function further. Yeah. Oh yeah, maybe we'll add some more things, for example, like verifying it and things like that. So another indicator that shows there's room for improvement is the config part of parse config, which implies that two values returned are related and both part of one configuration value. We are not currently conveying this meaning in the structure of the data other than by grouping the two values into a tuple. We put in a struct if we want, but you know, instead put two values into one struct and give each of the struct field and a meaning name. So for example, we can do it like that. We will have a config struct, and then we would and then we return the config struct instead. So, but this time we have to clone it to create a new struct, because yeah, does it explain why? Like because this struct lives too long or something? I don't know. Maybe it will in the future. Like, yeah, if it's a reference, then it's kind of limited, because if the vector dies, then the struct has to die as well. So yeah, but let's replace this with this. Then now we have a struct with query file name, and then we would make a clone. We don't want a reference to the string anymore. We create this new struct and then return it. Yeah, probably it will be very confusing, because like if this is not a clone, then this is the reference, and then this is also the reference, and then yeah, no. And then now we also have to change this, because now we change this into config, and then config dot something. So actually all of these has to change, otherwise it will be broken. So change here. Right, we don't want this. Yeah. added a struct name config. That's what we have done. Number of ways to manage. Yeah, I want to know how to manage this string data. I think a big part of the hurdle in the learning curve is like how to manage the strings. Easiest to somewhat inefficient is to call clone. Make a full copy of the data. Take more time and memory than starting a reference. However, cloning data also make our code very straightforward because we don't have to manage the lifetime of the reference, giving up a little performance to gain a simplicity that worth our trade-offs. The trade-off of using clone tendency among many Rustaceans to avoid using clone to fix ownership problem because of its runtime course. In chapter 13, you'll learn how to use more efficient method in this type of situation. But for now, it's okay to copy a few strings to continue making progress because you'll make this copy only once and your file path and query string are very small. It's better to have a working program than a bit inefficient and try to hyper optimize code on your first pass. As you become more experienced, that it's easier to start with most efficient solution. But for now, it's okay to just use clone. Yeah. Or the debugging would be a nightmare if you don't do that. Yeah. They've updated main, so now we have all those things. Now query and file paths are related because they are in the same struct. And they are called config right now. Creating a construct for constructor for config. So now we may want to check if the file name and the text strings are valid. So we want to have a new function now, improve config. So this is a new method in or associate function. How do you call those? Yeah, when you create a new struct, then this will run, right? So when you call new, you give it, so instead of pass config, you will use this now. So instead of calling that pass config, it would just be like config dot new, I think, not dot colon new. And args, yeah. So we just rename, or like, yeah, the pass args or pass config function basically is like the same as config new. So let's just make it config new. These are quite straightforward. Fixing error handling. Oh yeah, let's compile and run again because I'm so dumb that I would make a lot of silly mistakes. So that's good to always check. Fixing the error handling. So now next thing that we don't like is this very silly error. Should have been able to read the file. What should we do? Okay, fix our error handling. Record attempts to access the value in args vector. Cause the power panic if vector contain fewer than these 3 items. So if we run it without the argument, we have a panic because we don't have args 1 and 2, and it will be accessing something that is not there, and it's panic. Yeah. So now what should we do? So we should, when we do new, we should check the length before we try to access it here, right? So what we do is like if args length is less than 3, then we would panic ourselves. Not enough arguments. So this time, instead of this like very cryptic error message that the user won't understand what's going on, this time we just tell them not enough argument, which is fair enough. So if we run this, then we just say, oh, am I missing something here? Where's my beautiful error message? Yeah, here. Okay, here actually we do have. Yeah, so before it panic and said index out of bounds, is like what's going on, because your user don't necessarily like look at this code and say, oh, the index is out of bound here, right? This is more or less for us, but here this is like for user, not enough arguments. Then they know, oh, because this is intended behavior that if you don't give enough argument, your program will terminate and give you a set phase. So it's like our guest new. So extra few lines of code, then we can see our custom error, reasonable error message. Yeah, sometimes we don't want to give our user too much information because they are not there to debug our code. Using technique we use isn't the best use here. Yeah, code panic is better because what you gotta do if there's not enough argument, right? So you just panic and give a appropriate error message, tell the user run it again with the fix. We have already discussed about that. So now we want to return a result value that will change a config instance in a successful case and will describe the problem in the error case. To change the function name from new to build because many programs expect new functions to have never failed. Okay, interesting. When build is communicated to main, we use the result type to signal there's a problem. Then we can change main to convert an error value into a more practical error. So now let's change it. So we'll call it build. This is more complicated, so result will be either a config, that's the successful case, or there is a string that is the error message. So yeah, this will return error, and then otherwise okay will give us our struct. So we have static lifetime. Error values always be a string literal that have a static lifetime. I think we have come across this in one of the Rustling exercises. I don't understand, but I just use it. So yeah, I guess it's like because the error message, the lifetime is kind of fixed. So this is our build. So let's do this instead of our new. Oh, we have some problem here, isn't it? Or what are you saying? The code does not compile. What's going on? Let's read on because it said this one has a problem, or maybe because what have we done here? Maybe because we haven't fixed the main body. I don't know. Handle error case and print a user-friendly message. We need to. There's something hiding here. Yeah, this one of course won't work because there's no build here, no error handling and stuff. Okay. But we can start working on this one. Yeah, and then we now have to change the main instead of. So now we have processes. So we need processes. We'll put it here for now. And then when we have a so we call it build, then we will unwrap or else. So we would. I forgot unwrap or else. So I have to do it here. I have to handle my error here. Oops, no. I forgot what I have copied. Like that. So so if it is an error, yeah, so I guess this is checking if it's an error, then it's problem processing argument. If it's if it's okay, it will unwrap. If it's not okay, then we would run the, like we'll capture the error, and then the error will be here, and then we'll return process exit 1. I think that's quite standard here. Yeah, unwrap or else will define a custom non-panic error handling. So because before when we use expect, then it's like when it has a panic error. So when it has an error, we will panic with a custom error message. But unwrap or else is not panicking, but you can define what's going on. So if the result is okay, then it will unwrap. It will just assign it to config. Return inner value. Okay, it's wrapping. However, if the value is an error, this method calls the code in the closure, which is an anonymous function we defined. Oh, so this is kind of like lambda function, which is this thing here. Anonymous function. I've seen this a few times and I'm confused what it is. So it's kind of like lambda function. Pass as a argument, so the error is passed in as error, I guess. We cover closures in more detail in chapter 13. Unwrap or else will pass the inner value of error, which is this case the string not in argument that we added in the listing. Error appear between vertical pipes. The code in a closure can then use the error values. Yeah, this is capturing the error values, which is the string. Yeah, we have to use the process. It will. So we'll print the error value, and then we will call the process exit. So it will also stop the program like panic. And then now we'll return the number, which is 1. Yeah, similar to panic. No longer get all the extra outputs. So this time so this time it's more clean. We don't have this like nocturne reverberable environment display a backtrace thing. We'll just print out the argument and it will just stop because we just call process exit. So let's try. Yeah, okay, cool. This is what we do. Extracting the logic. So now we want to also take the logic out, like so we would call it run. We just give it the configuration in run, and then so the parsing needs to be separate, but then like the logic also needs to be separate. That will hold all the logic currently in main function that isn't involved in setting up a configuration or error handling. When we're done, main will be concise and easy to verify by inspection. Then we will have to write tests for other logic. Making a small incremental improvement. So now, so search for this. So this thing, even reading the file, will be extracted. So we want to make the function run. I think it doesn't matter where you put it, so we put it here for now. And then this one will become run config. So config will take in a config, and then we take the file path and then read the file, and then this silly error message again, and then this. So we will start working on those. The run function also can return an error. So we will also do the result as a return type, and then content, we again try to read the file, but we have question marks, so we just relay the error back. So we are reporting any error. I remember what this means. It's just like any error, and then if it's okay, it's just okay. So this is what we would do. So now our running config will either have a whatever error, or it would just be okay. So yeah, trait object that, yeah, it means that, oh, we have to also bot in the error, of course, otherwise that trait object will fail because it's not in scope. We have to do this as well. Oh, use. So yeah, and then we will cover the trait object, these trait, especially this one. For now, this means the function will return a type that implements the error trait. Basically, most of the errors. Don't have to specify what type. Flexibility. Give a short for dynamic. Okay. Second, we have moved the call to expect in favor of the, yeah, so instead of just like flow in a silly error message without panic, we just relate the error back in the return. For the caller to handle. So third, run function is now return okay. Yeah, by using the empty brackets, idiomatic way to indicate that we're calling run for side effect only. We don't actually return something. And then now we can try. Oh, we forgot the config. We forgot to put in the arguments, but this time it doesn't compile. I've done something wrong. Yeah, we haven't handled the error, but I got something different. Anyway, I have to handle the result and error variant. So what we can do is to change the main if we have an error during run config. Then we'll print an error and exit. It's very silly, but application error. But this is better because we can report it gracefully. Application error here. So yeah, not enough arguments. What if we have arguments and then something.text? No such file or directory. Now this time it will tell us what's going on because I don't have this file. Yeah. This time we don't need unwrap or else because we don't actually capture any value here. So I will use if let instead. So if it is an error, then this one will capture the E, and then we can use the E here. Yeah. So unwrap or else if we want to capture the value, then we handle the error here. But if we have, like, you know, if we don't care about the value because there's no value returned, then we can use if let. Splitting code into library crates. Now we can move things into our librs. So in our librs we will have the config and then run and everything, so which is just these things. But it won't work for now if we just move it like that. Oh, I also have to move the use. So use error, use file, need to move. So process stay because process and environment stay, because we need the environment to read the arguments, and then we need the process to end the process, which is basically what main will do. But then these two would be here because using them here. So save. But this one still won't work because yeah, there's also my mistake that I haven't made them public. So this one needs to be pub, and this one also needs to be pub, but it still won't work according to the little crab on the other side. Something's wrong. Build keyword. So yeah, what else do we have to move? Definition. Use the pub keyword. Yes. Oh, we haven't bring the config here. Yeah, because we're using config as config as if config is in scope, but it's not. We have to call it in because yeah, so that's why we have to use mini grep and then config, because lib.rs is mini grep. So yeah, and then also run is in mini grep, so we have to do, so we go back to main, so we can't just do run, we have to do mini grep : run as well. Does it work this time? Oh, forgot something. Use undeclare. Oh, what's wrong? Should be connected, but why I got an error message compiling? Did I do something wrong? Did I put it at the wrong place? Oh, where is, I thought I pasted it in. Oh, I pasted it in the wrong place, that's why. Silly me. Okay, like, where is it? Okay, here. Yeah, put it in the wrong file. Never a good thing. So yeah, I'm putting it here because I use it here, right? So this thing. Oops. Oh, I forgot to make it public again. Yeah, these two need to be public because I'm accessing them. So this pub. Yeah, it's better to make a mistake than just copy and paste, because then I know what's wrong. And then we also have something that I forgot to make it public. Unwrap, what else? Private associated function. Build here. Oops. Pub. Yes. Okay. Yes, it works. Let's do something that works. Poem. Yeah. Okay. Cool. Cool stuff. It works. And then you have to go a little bit faster. I'm actually going to Poland later today, so I have to go to the airport and I don't want to be late. So let's get chapter 12 finished, and then we'll come back another time when I come back or when we have time. There's still a lot to do, to read, but we are getting there. We're getting there. Okay, so it's kind of looking more decent, our project. Okay. Extract the logic. Various arguments and check return value without having to call a library from the command, a binary from the command line. Now we can write the TDD. We can write the test-driven development. So yeah, like TDD is basically you write the test before you write your code. So yeah, it's very different from what we intuitively do. So write a test, first of all, it fails, that it doesn't work, but that should describe what we want, the behavior that we want. And then we go to fix the code so that the new test passed. Yeah, fail for the reason you expect. So it's like, oh, because, for example, there's a new feature that we don't have right now, that's why it will fail. So we'll write the test, and then we would write to modify, so add new code, add the new feature, for example. We factor the code, make sure that tests continues to pass. Like you have to test everything, not just testing the new tests that you have added. So everything should pass, even adding the new tests. Then rinse and repeat when you want to add another feature or change some behavior. So it's not just adding a new feature. For example, you want to change some behavior, or you found a new use case that you want to tackle, then you should write a test case there, and then you should so currently it failed because that case is where you found the bug, and then you fix it, and then make sure everything passed, and then rinse and repeat. So first of all, we write the test. What do we want to write the test? So we'll develop the function called search. We don't remove the print line statement that we used to check the program behavior. Add a test module. So not this. I think is this. This. I don't think we are using this. Let's comment it out first, and then we'll clean up at the end. Also this one, we don't need that. What do we want to do now? We want to write a test. So go to librs, and then write a test, module test. So this is kind of like what you normally do. That's how you write the test. Add it here. This is standard. This is all standard. This is standard. This is standard. Run result. Query equals to duct contain slash plus save blah blah, and then assert equal. Okay. This is how we write the test here. Assert the value of the search function will return something that has this line. But we don't have a search function yet. This one won't compile for sure. Doesn't even compile. The search function doesn't exist yet. We just add enough code to make it passed. So you may think it's a bit silly. So we just like, oh, how about we just search, just return, say fast and productive, right? So we add this in here, just a public function. It will return a vector, but it will still it will compile, but it won't pass the test, I think. So what do we want to do now? Now we have to explicitly define the -a, because the content we will probably relate the content back, so it's a reference to here. So if we forgot the lifetime annotation, it won't compile, because search, we put in a content, which will be a reference string. Wait a second, we're doing nothing here, so there is data reference by a slice needs to be valid for the reference. Yeah. Contain a borrowed value. Because it's borrowing something, and it's worrying for the compiler, because I don't know where this came from. It's borrowed from something, but I don't know where it came from. I want to know the lifetime of it. Then you kind of hinted at it's like, oh, it's the same as the content. Then it's more happy. But even though we are doing nothing here yet. But even like if it's bothering anything, then it's just very ambiguous and the compiler will be sad. Yeah, and also Rust doesn't apply like those 3 rules, right? Rust doesn't know which rule to apply because we have 2 arguments and they're assumed to be different. And if it's just one, then it's fine. It's probably assumed it's the same as this one, but because there's 2, so it's not okay. So now if we want to run the test, it will fail because it because it's nothing there. It's never have this text in it, so no. So we want to pass the test, so for line contents.lines, you can do something super silly. You can just oh, I will just return this line, because that's why I think always like TDD, like don't follow it as if it's religious, because like if I follow it religiously, right? I would just make a I would just return this, right? I would just return say fast productive, and that's it. Like that's what I should return, and that's, you know, that will pass the test or something like that, right? Like yeah, so this will probably pass the test. That's the minimal code I can write to pass the test. So this is TDD. So if you want me to do more, you have to write another test. So yeah, like don't follow it religiously. Get the idea and just, you know, yeah, you also have to apply common sense here. So for it to be usable, we have to write something like this to make it work. Yeah, so TDD is not like playing a game. He's like, oh, I'm smart. I just need, well, minimal code. I just, you know, but yeah, eventually you want your program to work. So yeah, otherwise you have to write million test case or use something like property-based testing or something. So aligned in contents.lines, then we want to do something. So what do we want to do is to do the search, right? So but we haven't implemented yet. So contents.lines, so .lines will return the line by line, and then we want to do see if the query is in there. So how do we write that? So if line contains query, so use .contain to check if line has that text in there. So result push, yeah, so if it's in there, then we'll push. So we have to make an extra result to save it, and then we would, because it would give all the results, like everything that has it. So it will be a vector of things, which would be the lines, and then we'll give back the result like that. Now the search function should return only the lines that contain query, and our test should pass. Let's run the test. Then try. Oh, okay. It works. Use the search function in the run. Oh, we still have too much chapter. Oh my god, this is a big project. Use the search function in the run function. So we can do that, or we can do something even. Oh no, wait. Okay, now we're done with the search. Now we put it back to the run. So, so in our run, we have read the file, and then. So here, what do we want to do now is to for line in search, And then, so so this one search should give us back the result in a vector, right? So we would kind of process them one by one by using this for loop, and then print out all the lines. So let's change that. So for example, if we run this, it should give me frog. How public like a frog. But if we search body, then we'll get two answers. Because I'm nobody and you are nobody, and how dare you to be somebody? It's all have body. So we got three results. And then if we have some word that's super difficult word like the book know that my favorite word is monomorphization. Yeah, so if we search for that, oh no, not this, I want a monomorphization. Then oops, now I have to delete it. Now we should have nothing, which kind of cool. Yeah, so it works, but I think we're quite far from done. We still have two more chapters, so let's go there. Environment variables. Okay. Oh yeah, we have the user config file, right? So we have an RC file somewhere. Okay. Improve mini grip. So we already have something that's working, but we want to have extra features. Like option for whether it's case sensitive or not, and so it can be turned on via the environment variable. Yeah, because we don't want to make it well, we could make it a command line option, but then user have to do it every time to apply. But if we make it an environment variable, then user can set it once and it's there to stay. So now we'll add a new search case sensitive function that will actually call the environment variable that has a value. We'll continue to follow the TDD principle, not religiously but smartly. And then yeah, so we do like test from run result to case sensitive result. So now I want to add one more test to test this new case. So here we would add a new test. So we'll add new function here. I don't like when this multi-line of text is a bit crazy like this. The indentation is driving me crazy. But unfortunately that's the case, so we have to do that. Right. So case sensitive type Rust in a very interesting case way. Will it be able to find Rust and trust me? So search case sensitive should give you the right answer. So UI duct tape. What? What was going on? Oh, we also changed this. Okay. It's also changed duct tape because this is capitalized. It should not find the other one. Yeah, it should only find productive. It should not find the duct tape because it's because it is not the right case for it. Yep. Yeah. Okay. Right. So how can we implement this function? So we'll do it here. Just copy this, put it somewhere, and then we'll look at it together. Search case sensitive. Query, so the string is content, and then again we have to denote the lifetime, and then query equals to query to lowercase. We added this extra line here to make the query non-case sensitive, because they'll all be lowercase. I think we also have to, yeah, we also have to do like to lowercase dot contain, because the content also have to be lowercase. So no matter which case you use, we always compare the lowercase to lowercase, so it's case insensitive. That's what we're doing here. So if we run the test again, we would, oh sorry, this is not the test. Run the test. Not found in this scope. I forgot to noise pop. What have I done? I bring everything in. Oh, wait a second. Did I type something wrong? Search case. Did I put it in the wrong place? Search case insensitive. Which line is the complaint? 71. One is this one. I think I may paste something in the wrong place. Maybe. Search case sensitive. Why is it complaining 71? Am I reading it wrong? What's going on? Did I not forgot to save? Maybe I forgot to save. Let's try again. And yeah, okay, it passed. I just forgot to save. That's why. Silly me. Okay, so now they pass, and then now we will have this new function that we could use in run probably, but we have to change the configuration. So in the struct config we have a new entity. We will have a flag to kind of save whether it's ignoring the case, this boolean. But how can, okay, so now if it's ignore case, then run search case insensitive. But if it is case sensitive, then it will just run what we used before. So let's reset search. So here, instead of search that, we would, instead of just search, we would do this, and then we will print out the results. So let me just copy the whole thing, because we have to also oh actually yeah, it's fine, because I have to print out the results separately now this time, because I am saving it here, because I'm using if else. Right, so now how to change the environment, how to read in the environment variable, how to check it. So there's also something in the env module that can help us. We'll bring the module as a scope. So we already have n in the scope actually. So now we have to do is to call it. We have to use the var function, and then we have to check for ignore case, which will be the environment variable. So what we'll do here is that in our build, oh okay, yeah, it's in the librs, so we don't have that yet. So let's put it in the librs here. So in the build, we would also read in the environment variable. So ignore case is okay. So where is it? Okay, so after this too. So ignore case is env var and read ignore case, and then it's okay. So I think it's true or false. So this is true or false, then this is true or false, I think. Oh yeah, so this will also give us a result, and like it's okay means that if it's okay then assign it, and if it's not, I don't know what's going on. Let's check. I think the value of the environment variable, it will return error variant. So its okay method is to check whether the environment variable is set, means that the program will, so if it's not set, then we'll have an error. So if ignore case isn't set to anything, it's okay, we'll return false. So it's okay, we'll return false if it's not okay. Right, so it will just perform a case sensitive search. So let's recap. Expect if there's an error, you just fall in panic and custom error message. Unwrap, it will unwrap the value, assign the value to whatever you want, and then error you can handle it within the bracket of it. It's okay is that if it's okay, if it's the value, then it will assign, but if it's not, then it will just give you a false. That's very ignore case. So one function can read the value. Give it a try. Run our program. So it has been saved. Without the environment variable set and with the query to any line that contain the word to in lowercase. So let's give it a try. Missing ignore case. Yes, I did forgot that. Let's see. Yeah, now we have to also return ignore case. So it is here when I return. Now this one I also have the ignore case. Yes. Yeah, so now I'll have this 2 line, which is correct. So on the program of ignore case set to 1, ignore case equal to 1, and then do this thing. We have more because the 2 with capital T will also be here. So now yeah, so this now if I run it again, it will be, ooh, it's not persistent. Set the environment and run the program with a separate command. Okay, I'm not using PowerShell though. What's going on? Remove item. Well, it's not persistent. Yeah, I think it's only for PowerShell. If you do all this, it will be persistent. Okay. If you want to make it persistent, you can save it in the environment variable file or whatever. It's fine. Yeah. So now it kind of worked. Oops, that's not what I meant to do. I just like pressing the save button too much. Okay, last page. And then after quite a day, I have to go to Poland, and PyCon Poland to be precise. It's in a place that the name of the place I can't pronounce. But if you are interested, go search for PyCon Poland. It's happening this week, Thursday, Friday, Saturday, Sunday. And yeah, it's nice. It's nice to be meeting new friends and old friends, and I'll be there talking about a lot of things. So yeah, check it out. Writing error message to standard error instead of standard output. So whoa, something's going on the street. Yeah, now we want to separate standard error and standard output, because print line Marco, we're just writing all the output to the terminal. Only capable of printing to standard output, so we are all putting everything on standard out right now, even including the error. So check where errors are written. Currently being written to the standard output. So yeah, so we have to divert the error somewhere else. Yeah, because now the error will also go to the output. So we have to put the output, the error in the standard error. So instead of print line, we print line. then it should go to the error instead. Okay, so if we use ePrintLine for all the errors, in the main, right? Yeah. So if we do what it does, this thing, so we should have nothing. So yeah, we should still see the error, not enough argument, and our file should have nothing. But if we do something that has a output like that, then we of course don't have any error message, but we then see the output being piped here. Oh, that's quite easy. We just have ePrint instead of ePrintLine instead of PrintLine. Then instead of going to the error will be printing out separately. They will be shown on the screen. But if when you use those like piping operators in your shell, then only the standard output will be piping there, not the error. So I guess that's it for now. And there's a lot of crazy thing going on out there. Is it like there are kids playing? That's why. Okay, so that's it for me for now. Yeah, I'll be very busy for the rest of the week. I'm sorry, but we'll be back. We will keep learning. Next time we'll do functional language features. Iterator. Yes, iterators finally. Next time. So thank you so much, and I've been it's an hour. We'll go through one chapter per hour. Great. So when we go back next week, then we'll probably next week. I don't think I have time when I'm away, but we'll probably do more. And keep learning Rust. So hopefully by the end of next month we would be able to tackle some project. So yeah. Good. Good. So I would see you next week. Or follow me on Twitter if you want to know what's going on in between. Twitter, Mastodon, whatever. Just follow me. Yeah. Good. See you.